Okay, the purpose of this recording is to familiarize you with a few Excel skills that you'll need for the PGE 301 class. So the first thing we need to do is get your Excel set up to have the proper functions available. And two of the things that are important for an engineer to have available in Excel are the analysis tool pack and the solver. So let me just go through this real quick. So now analysis tool pack and solver. So if you go to the file menu in Excel, and I'll do this after I describe it to you. Go to the file menu and you get this pull down menu, and at the bottom you see options. So if you choose options, then it pops up this screen. I'm just showing part of it. Go down here and click on add-ins. When you click on add-ins, this dialog will change, and at the bottom you can see this go button which says manage Excel add-ins. So you click on that go button and it should pop up this dialog box. And this dialog box, you want to choose analysis tool pack and solver add-in. Now, depending on what version of Excel you have, this will be different. Hopefully this is the same as the current version that you have. I think my Excel is the newest Excel. But anyway, so that should get you there. So let me go ahead and do that myself on my computer here. So if I pull up Excel, let's just make a blank sheet here. So if I go to the file menu and I choose the file menu, go down to options, pops up this dialog box. I click on add-ins. It has a list of things that are already installed. So you can see actually analysis tool pack and solver are already installed for me. But I'm going to go ahead and add it, try and add it anyway. So I click on go down here at the bottom of that dialog box. And you can see I have a checkbox. I can choose analysis tool pack and solver add-in. You can choose these other things too if you need to know about Euro currency, or if you're a VBA programmer, you might find that convenient. But this is all we need for class. Okay, so that covers that topic. Let me go back to PowerPoint then. Go to the next slide. Okay, so the next thing we're going to do is we're going to learn how to write equations. This is something you probably already know how to do, but I want to cover all of these topics and make sure that everything is familiar to you. So there might be some things that are new. In addition to writing these equations, we're going to make some calculations and make charts. And engineering type charts, which are XY plots, or what you would call a scatter plot. I'll also show you how to make what is the equivalent of a contour plot. So first of all, let's just go through the text here on the slide. So equations refer to cells, and an equation starts with equals. So I think you probably already know that. But let me talk about what I call relative cell references and absolute cell references. So if you just put in A20, I would call that a relative cell reference, and that means if you copy that equation that has A20 in it and you paste it somewhere else, Excel will detect how many columns and rows you moved, and it'll update that A20 to reflect that movement, and so it'll change the address of the cell that equation refers to. And I'll show you that. Well, maybe I'll show you that right now. Let me go ahead and get back to Excel. Okay, so let's say this is the temperature, and this is time. Okay, and so we've got, say the temperature is 23 and the time is 1. So I'm going to write an equation over here to be the time, this is just BS here, temperature index, okay? And so I'm going to say that's equal to the temperature times the time. Okay. So now you can see that's F5 times F6. If I copy that equation and I paste it somewhere else, actually I'll just paste, Control V, paste it. You can see that it's no longer F5 times F6, it's K11 times K12, because I moved over 1, 2, 3, 4, 5 rows, and I moved down 1, 2, 3, 4, 5, 6 rows. And so it added, excuse me, I moved over 5 columns and I moved down 6 rows. So it added 5 columns to the column reference and it added 6 rows to the row reference. So F5 turned into GHIJK, so 5 more, turned into K for the column. And so that was the F, the column reference, and then the row reference 5 added 6 to that, so it made it into K11. Hopefully that makes sense, okay? And so if I needed to refer to these guys, I didn't write the equation in the proper way. So let's go back to PowerPoint for a sec. So we needed some sort of an absolute reference in order for that equation to be able, for me to be able to paste that equation to a different location and make it still work. So absolute references have the $ in front of the column or the $ in front of the row. And if you have a $ in front of the row, the column and the row, then that's a completely absolute reference. Doesn't change at all. You can also make it absolute for column only. Just put the $ in front of the column. You can make it absolute for row only. Put the $ in front of the row. So if we go back here, if I change this equation, let's delete this equation over here. So if I change this equation to F, $F, $5, and $F, $6, then I can copy and paste my equation somewhere else in the spreadsheet, and it doesn't change at all. The cell references stay exactly the same. Okay, so that's just an example. That's a very simple example. You probably wouldn't use an equation like this, but we'll come back to this in a minute. The other thing you can do is you can copy an equation down, and so you see I select the cell with the equation, and I drag the mouse and select a bunch of cells below, and I hit Control D, and it copies that equation down, okay, to the cells that I've chosen. Or I can copy an equation right, so Control R. So I could do that as well. Okay. Let's hop back to Excel. So that covers everything that was on this slide here. If you have any questions, please interrupt. The TA can stop the recording and answer your questions. Okay, so if we go to the next slide. Now what we're going to do is we're going to do what I call 1D and 2D calculations plus plotting. And so we're going to build a spreadsheet that looks like this. And this is a spreadsheet where I've got the equation for a circle. I've got pi written in here. And given a radius value, I calculate the area, and then I plot area versus radius. Down here, I'm doing a chart. So this is two-dimensional. So I've got two different variables that are changing, and I'm plotting up the implications of those changes. So I've got on across the columns here is gradient in a fluid in PSI per foot. So that's if I have a column of, let's say I have a column of fluid that has a pressure gradient of 1 PSI per foot. So if I have 1 foot tall column, that's 1 PSI. If I have a 2 foot tall column, 2 feet times 1 PSI per foot is 2 PSI, and so on. So I can basically see as I stack a column up how the pressure increases. Although I really shouldn't be stacking things up, we should be thinking about drilling down. So as we go down into the earth, that accumulated pressure is calculated by multiplying the gradient, which is here, times the depth, okay? And then you can see so I have a gradient from 0.1 psi per foot to 1 psi per foot, and here I have depth from 500 feet to 6,500 feet. So we're going to construct this table and have Excel calculate the values for if my gradient is 0.5 psi per foot, what's the pressure at 6,000 feet, and so on. And then we're going to make a plot of it. Okay, and so that's what I'm going to do, and I think that'll probably cover the time that we have for today for learning things about Excel. We might learn some other things at another time. So let me go back to Excel. Okay. Let's start by typing in cell A1, equation for a circle for area for a circle. And then we're going to have some constants, and the one constant I'm going to specify is pi, and I'm going to say pi is 3.1415. So that's 5 significant digits. Okay, and then we're going to have a column for radius and a column for area. Okay, and we're going to have radius go from 0.1, 0.2, and I could keep typing that down, but Excel has a function where if I'm having equally graduated increments, I can copy that down by grabbing, you see that little square in the bottom right hand corner of my selection, so I can copy down, and now I've got 0.1 to 1. Okay, so that's my range of radius, and then in here I type equals, and the equation for an area of a circle is pi times radius squared. So use caret for squared. Okay, and then I can just select that and do Control D to copy down, and you see that the equation is screwed up. Okay, you probably know why it's screwed up, because I copied down this equation right here looks 3 cells above to find the radius. Well, or excuse me, to find pi, but pi is way up here, so I needed to make an absolute reference to make this equation work if I wanted to copy it down. And I'm only changing the row value here when I copy down, so I'm only going to make it absolute with respect to row. So B $3, but I could do $B $3. Okay, so now I corrected the equation in cell B6. Now when I copy down, I'll get the right answer, because every equation refers to B3 for the value of pi. Now it turns out Excel knows the value of pi, and so I wouldn't have had to have typed in a cell like that to have this constant. So I could have done something else, and the value of pi in Excel is given by typing the word pi, open parentheses and close parentheses. Okay, and so now that gives me the value. That gives me the value of pi in that equation. I can copy that down, and I have a few more decimal places because it's defined out to a further number of repeating numbers than I put in. But that's where I get the answer. Now notice I changed the number of decimal points in here. So Excel has this on the menu bar, it has a increment of increasing decimal places and decreasing decimal places in the toolbar, so that can be convenient. Okay, so now I've written my equation. This might be a good place to ask a question if you need to. The next thing on our list to do though is to make a plot. So now I want to make a plot of how area changes with radius. And so in order to do that, I want to plot with a line on it, but I do not make a line plot, okay? This is not a line plot. I want to do what's called a scatter plot, okay? And so what I do is I choose one of these scatter options. I can have just the data points. I can have the data points in a curve and markers with smooth lines. I can have the markers and lines with straight lines between the symbols. I can have line only for the increment, although it looks pretty smooth, but it's actually stepwise straight between the different data points, are going to have a smooth curve, which does a spline approximation between the data points. So I'm going to pick this guy, which is the markers with straight lines between them. Okay, and you can see now that I have a chart. It shows how area changes with radius, but I don't know which axis is what, so I want to add labels. So we'll go up here to Add Chart Element. This is part of the chart tools in design, so I'm going to add a chart element called Axis Titles. For the primary horizontal axis, I'm going to type in radius. Okay, and then I want to add a label for the primary vertical axis, and I'm going to type in area. Okay, so I think that's all I wanted to do for that. Any questions? The TA can stop and take questions. The next thing we want to do is this pressure thing that I talked about. So subsurface fluid pressure map. So specify pressure gradient and calculate pressure as, and I'm just going to write out the equation in words. Pressure equals gradient times depth. Okay? So what I'm going to do is I'm going to write across the columns, I'm going to have gradients in psi per foot. And so we'll go from 0.1, 0.2. Sorry, when I tab around on my Excel sheet, it turns my video on and off. Sorry for that. Okay, so now I'm going to run this over to up to 1 psi per foot. And you'll learn in, well, you'll learn in this class, but you also learn in geomechanics and some other classes. Typically, we don't have any stress or fluid pressure in the earth that's greater than 1 psi per foot. Well, actually, that's not true. We usually don't have any the vertical stress usually is never greater than 1 psi per foot. Okay, so there's that column. And then over here, I'm going to do depth in feet. And we'll start at 500 feet and go to every 500 after that, so 1,000. And go up to, what did I go up to? 6,500 feet. Okay? And so the pressure, calculate the pressure. I've got a depth of 500 feet and a gradient of 0.1 psi per foot. So that's 500 times 0.1 gives me equals the depth times the gradient gives me 50 psi. Okay? Now, I want to fill up this whole table by copying down, Control D, and copying right, Control R. But I didn't do this right because essentially if I look at this cell, for instance, this cell, if you double click on a cell, it'll show you what cells it's referring to. So it's referring to the pressure at the previous depth in this gradient column and the pressure at the same depth in the previous gradient column. So I want it to be referring to this row 20, all these row 20 values. So this cell right here should have a pressure gradient of 0.2 and a depth of 3,000. So how do I do that? Well, I need to put in some absolute references, but they can't be total absolute. They just have to either refer to rows or columns. So for the gradients, I want to always have the same row, which is row 20. And so B20 is referring to the gradient, so I put in a $ before 20. So when I copy that right or down, that row will stay as 20. And then for the depth, it's all in column A. And so I put the $ in front of A, and that'll fix the column to not change. Okay? So now I've made a correction on the first cell. Now I need to do my copy right and copy down again. So I copy down and copy right, and now it's fixed. Okay, so we take an example at 5,000 feet depth with 0.7 psi per foot gradient, I should have a pressure of 3,500 psi. Okay? So hopefully that's straightforward. I've calculated that. Now the last thing I'm going to do is I'm going to make a plot of this. And now this is a two-dimensional data set. I've got two variables which are changing, okay? And so what I need to do then is, and hopefully that depth label doesn't cause me problems, but I want to select the whole table plus the values of depth and gradient. And I'm going to insert a plot. And this doesn't come up in this default here, so I need to click on, I think recommended charts is a way. This has changed a little bit from the last time I've done it. But it's an area plot, a surface plot actually, and I don't see that as one of the default choices. So I'll have to click here. And here's some recommended plots. It's telling me I don't want any of those. So we'll go to all charts. And again, if you have Excel on a Mac, this might look different, or if you have a different version of Excel than I do, this might look different. But what we want right here is called surface plots. Okay, so I'll click on surface, and you can see that it's going to make some sort of a, whoops, that's a three-dimensional surface. I don't want a three-dimensional surface, actually. Let's delete that. Let's try again. So we're going to insert recommended charts, go to all charts, click on surface, and then notice I have a couple different 3D options, and I have some 2D options. So I want to pick the flat one like a contour map. Okay. And it is goofed up, it appears. So I think what I need to do, sorry about that, this label there is causing me problems. So I'm going to move the whole chart. I'm going to select the whole chart, and I'm going to move it over a cell, and then I'm going to move this label over here. Now if I do this, I think this will do it correctly now. When I had that first cell filled, I think it didn't realize that I had my labels for my X and Y directions. So let's try again. Making mistakes is the way you learn, right? So here's surface plot, and we'll choose the map version, and that looks correct. Okay, that's much better. And let me change the size a little bit so it fills it up. And look, I have a contour plot, and here's the legend down here at the bottom. So this blue is 0 to 2000, the orange is 2000 to 4000, the gray is 4000 to 6000, and the yellow is 6000 to 8000. Now, I don't know how you get around the fact that Excel picks the most horrible colors as default colors. I just really don't understand why they don't use primary colors for their default colors in charting. So you can see I have a contour interval of 2000, right? So only every 2000 does the color change. I want to make that a smaller number. That's not as interesting. I want more contour lines on here, or more different colors. So what I need to do is well, let's click off the chart, so you can see it's not selected. So if I click on the chart and the whole chart is selected, then I can go up here under chart tools, I pick format, and then up here in the upper left corner I can pick what I want to format, and what I want to format is the vertical value axis. Notice there's a depth series and there's a horizontal category axis. So the depth series, that's referring to the different rows. The horizontal category axis is referring to the different columns. And then the vertical value axis, that's the value of the contour map, is what I want to change. So I'm going to click on that. And then over here on the far right, you can see I get a format axis box. And so I click on this columns here and choose axis options. You can see I'm plotting values from 0 to 8000 is the range, and I want to make the major value category, or the major units between categories, to be 500. So that means I'll get a contour line every 500. Okay, so now you can see that I changed the nature of my map. So now I've got a lot more contour lines. You can see more detail in there. So if you wanted to say, okay, I'm at 3,000 feet and a gradient of 0.5, so I'd be somewhere around, looks like that color is 1,000 psi. Okay, Not the best way to reference these values necessarily, but it does show you how to make a contour map or a two-dimensional chart. Okay,